We're going to be talking about frequency distributions again, but now we're going to be going a little more into detail about their features. So in the last lesson, we covered how to look at the data in Excel. So there's a check mark off of that one. And we talked about how to go from data to frequency tables using our COUNTIF function, and from frequency tables to visualizations. But now we're going to take another look at those same examples that we looked at before, except now we're going to be talking about the features of these distributions. In particular, we're going to be looking at their shape. There are a couple of shapes you should know after this. One is uniform distributions. Another one is going to be called unimodal. Yet another is called bimodal. And a special one that we're going to be looking at called normal. We're also going to be talking about center. We're not going to be talking about how to calculate the center of the distribution. We're going to be talking about how to think about the center conceptually in three different ways: mean, median, and mode. But we're not going to be talking about how to calculate it yet. Then we're also going to be talking a little bit about spread. How spread out is this distribution? And finally, we'll also mention outliers, gaps, and clusters whenever they're relevant. So recall example 1. Here we looked at a data set of 100 Facebook friends, and we looked at whether more of these friends are born in a particular month or another. Note here that it really seems to be that no particular month is super popular. This is what we called a uniform distribution. If you sort of squint and blur your vision a little bit, it's almost like there's a flat line here, right? And everybody is sort of hovering close to that line. No one month is more frequent in births than any of the other months by a lot. Some of these months are a little more frequent, but only by a little bit. You could see there's relatively little change from month to month here. Other uniform distributions also look like this sort of rectangle or flat shape. And these distributions might be anything from deaths occurring on days of the week. Is there any reason to believe that one particular day is more favorable to die on than another? Or in rolls of a six-sided dice. Is there a particular reason to believe that one side might come up more frequently than another? Not if it's a fair-sided dice. All right. So remember, this is now example 2. In example 2, we looked at the same data set again, and we looked at the age distribution in this sample. Here, we don't have a uniform distribution. No matter how much you squint your eyes, you're not going to see sort of a flat shape. You see a peak right here. And because of that, this peak, often called a mode, the most frequent member, the most frequent value, this peak makes this a unimodal distribution. So I'm not going to call it example 2 anymore. I'm going to call it a unimodal distribution. We'll add on to that. Not only that, but this shape is what we call skewed. So if I decide to just draw a light little sketch over this guy, we see that it has this long, what we call tail. This tail goes out towards the right side, the larger values. Because it's skewed and the tail is to the right, we call it skewed right. So it's not only unimodal, but it's also skewed right. You often have a skewed distribution when you have some sort of minimum or maximum value that these values are all bumping up against. So Facebook, I think you have to be 13 years old to sign up, and maybe a lot of 14 and 15-year-olds, their parents are not letting them sign up. So the bottom end of it, there's sort of a wall. There's like an imaginary wall there. And the most popular, at least in our sample, seems to be in the 20s. And some of the older people use it. There's no limit on that. You could be 100 years old and still use Facebook. So since there's no limit on that, that tail can go on for a really long time. Now, these outliers out here, they are often called, you could think of them as oddballs, but we call them outliers. Tails are often made up of outliers. Note also that because this is skewed right, if we drew a line of symmetry from the mode, and we imagined folding this distribution on itself, we wouldn't have two sides that match up, right? So we call this asymmetric as well. So we learned a lot here. It's unimodal, it's skewed right, and it's asymmetric. All right. Now, here we'll learn yet another term. We see there are these gaps. These are called gaps. Nice and easy. And if we had a couple of people clustered in a group, we call that a cluster. So a lot of these terms are pretty normal words that you would use in everyday life. All right. All right, now let's move on to example 3. In example 3, we were really interested in what the height distribution was in this sample. Now, compare this distribution to our previous skewed distribution. Is it skewed to the right or skewed to the left? Is there some sort of tail here? Not really. There's no real tail that I can see. But we do see that there are sort of a couple of places that are sort of popular modes, most frequent values. These are 64 and 69. These seem to be sort of the popular peaks. It's because we have one mode here and another mode here, this is no longer a unimodal distribution. This is what we call a bimodal distribution. So instead of calling it example 3, I'm going to call it bimodal. And is it sort of symmetric? Well, sort of. You could sort of see it as almost having maybe like 2 bumps, like that. So it's sort of symmetric, but not perfectly symmetric. There's no tail. There's not very many gaps. There's maybe a little bit of a gap here, but not very much. So this is what we call a bimodal distribution. Now, let's think about this. Height distributions. Well, our Facebook friends are both males and females. And since males tend to be taller than females on average, it might really be that there's a cluster of males up here and a cluster of females down here that we can't see right now. So let's look at these two distributions, males and females, separately. All right, so here's just the distribution of male heights from our sample. Notice that here it's not really asymmetric, because when you look at this mode, here's our mode right here, and you draw sort of a line of symmetry, and you imagine folding it on itself, then you get a pretty good you get a pretty even looking hill right there. Let me just erase this line real quick. You get a pretty even looking hill with roughly similar numbers of people on this side as on this side. So this is what we would call a roughly symmetric distribution instead of example 4a. It's also what we call unimodal because we only have one mode right here. All right, what else do we notice about this? Well, we don't really see a tail. And furthermore, it seems that this distribution seems to have a lot of people piled up around 69 inches, with a lot more people close to 69 and fewer people sort of farther away from 69, like at 75 or around 64, right? So this is what we call a normal distribution. You could think of a normal distribution like a pile, right? And usually a normal distribution, well, not usually, by definition, a normal distribution is both unimodal and symmetrical. Now, in a normal distribution, typically the mode as well as the mean or the average is going to be the same. To think about the word average, you might want to think of it like this in terms of distributions. Imagine cutting out this distribution, like out of cardboard, and then trying to balance it on your finger. Where the distribution would balance, that point, that's the mean, right? So although we'll learn to calculate this later, that's sort of the image I want you to think of when you think of the mean. Now, if we draw a smooth line around this distribution on either side of the mode, at about 60% of the height of this peak, so let's see, that's about 50%, so around here, at about 60% of the height of this peak, you'll have what's called the point of inflection. Point of inflection. Here's what's so dang important about the point of inflection. Although you can't see it very well from my picture, I'll exaggerate it. The point of inflection is where the distribution goes from being concave to being convex, right? So that's about right. And this point of inflection is going to be important later because this distance right here, this distance is going to be called, I'll put it up here, the standard deviation. Later, we'll learn exactly how to calculate that. But that point of inflection and the standard deviation is going to be really critical to our understanding of other distributions as well. All right, so here we see both males and females' heights plotted on this frequency distribution. So just so you could see, here's sort of our female distribution. And here is sort of our male distribution, right? Here you could see there's roughly a normal distribution for the females as well as the males, right? So we're going to say two normal distributions, right? They're both unimodal, and they both are roughly symmetric on both sides. There's no tail, no big gaps or clusters. There's a big cluster in the middle, and that's about it. And here, what we thought before was a bimodal distribution, we actually see there's actually two normal unimodal distributions instead.